How can sound escape when it cannot be understood? All you hear is vibration. We have to rely on these vibrations to collect data. Voyager 1 and Voyager 2 are critical to space exploration, providing real-time data from the far reaches of our solar system. These studies are very important to our understanding of the universe, although we may not explore these regions directly for years. However, NASA engineers are puzzled by some strange data returned from space by Voyager 1. Why should these strange messages concern us? For nearly 45 years, Voyager's missions have been critical to space exploration, providing the first major insights into the true nature of our solar system. Voyager 1 and Voyager 2, NASA's twin spacecraft, have become time capsules for generations to come. These studies have 8 records for data storage and 3 million times less memory than modern smartphones. Their data transfer is also very slow, about 38,000 times slower than a 5G internet connection. However, they are still at the forefront of space exploration. Our Sun and its planets move into interstellar space, a vast region called the Pacific Ocean. No explorer has ventured into this previously unknown territory. Scientists are combining data from the Voyagers with information from previous missions to understand the solar system and how the heliosphere interacts with interstellar space. The heliosphere, the Sun's magnetic field, may be more spherical than previously thought, contradicting previous comet-like models. The Sun emits a solar wind, which pushes a stream of charged particles onto the cold plasma, the interstellar medium. This interaction is like a pebble in a river. The boundary between the solar wind and the interstellar plasma is known as the heliopause, an important point in our understanding of the end of the solar system and the beginning of interstellar space. When Voyager 1 launched, we knew very little about where the heliopause was. As the investigation progresses, the boundaries of what we know are pushed. In 1992, after encountering Neptune, Voyager began seeing strong radio signals that scientists believed came from giant flares. These flares produce plasma that reaches the heliopause, conducting electricity and emitting radio waves. The interstellar medium outside the heliosphere is larger than previously thought, although it appears to be a near-Earth vacuum. By estimating the speed of the outer solar wind and measuring the time it takes to reach the region, the researchers were able to estimate the distance to the heliopause from 116 to 177 astronomical unit, AU. On August 25, 2012, Voyager 1 passed the heliopause at a distance of 121 Australian dollars and 60 cents. This transition was marked by several key signs. The particles in the solar wind began to fall, and the outer rays of the solar system became stronger. However, not everyone believed this evidence alone. Voyager 1's plasma instrument failed, preventing it from collecting particle density data. In addition, researchers expected the magnetic field to change after crossing interstellar space, but this did not happen at in 2012. A series of solar storms helped Voyager detect radio waves produced by plasma fluctuations. This is further evidence that Voyager has entered an interstellar region. Voyager 2 passed the heliopause on November 5, 2018 with little controversy. The plasma instrument worked and was able to measure particle growth and temperatures from 30,000 to 50,000 K. The solar wind slowed down and the sky's rays became stronger, but still not the magnetic field changed direction. The 2 Voyagers continue to drift away from the planet, providing valuable data from the unknown. But because research relies on decaying plutonium for heat and energy is lost every year. To conserve energy, NASA has eliminated systems, including heaters to protect the constantly working equipment from the cold. Despite these challenges, devices continue to go beyond their useful lives. In 2022, Voyager 1 malfunctioned the Attitude Acknowledgement and Communication System, AACS, which ensures that the probe's antenna remains grounded. Despite this failure, NASA engineers were able to solve the problem by switching to additional computing. As Voyager operations continue, NASA is exploring possible options. Travelers should be kept warm to prevent freezing of the fat that houses the antennae. Depletion of plutonium will limit its lifespan, but for now research continues to provide data from the far reaches of space. As we delve deeper into the mystery of Betelgeuse, the scientific community remains divided. Some scientists believe that the star's massive decline in recent years will cause it to go supernova, while others believe that this is just a phase in its stellar life cycle. Controversy has intensified as Betelgeuse moves erratically, leaving astronomers searching for new clues. One thing is certain. Betelgeuse will eventually go supernova, a cosmic event. This explosion can be seen from far away, and its brightness rivals the brightest objects in the night sky. When it shines, for a brief moment it can be seen during the day, a celestial sight unlike any of our generation. If a supernova occurs, Betelgeuse will collapse into it, releasing a large amount of energy. When the core explodes, the outer layers of the star are hurled into space at incredible speeds, creating a shock wave that reverberates through the universe. The remnants of this explosion can form a supernova remnant, a beautiful and complex structure of gas and dust that can persist for thousands of years, allowing astronomers to detect the death of a massive star. But what does this mean for the country? Despite Betelgeuse's proximity, scientists tell us that a supernova event poses no threat to our planet. At a distance of 650 light-years, the energy of the explosion dissipated before reaching us in any dangerous way. Instead, we are presented with one of the most amazing scenes we have ever seen. However, uncertainty remains. Is Betelgeuse's unusual behavior the start of something else? Could this be the first sign of a world change? While these questions remain unanswered, one thing is clear. Betelgeuse has captivated humans for centuries, and we're still on the edge of our seats. We are waiting now. With each passing day, astronomers keep an eye on Betelgeuse, scanning the skies for signs of a supernova that might, just might, occur in our lifetime. The fate of this mysterious star is one of the greatest mysteries in the universe, and once it is solved, it will undoubtedly change our understanding of the universe forever. Until then, Betelgeuse will serve as a reminder of the vast and unpredictable nature of the universe, an ever-changing tapestry of stars, planets, and galaxies, each with its own story to tell. And as we look at the night sky, we remember our place in this great dance of life, always watching, always curious, and hopeful. One day we will see Betelgeuse's last interstellar journey.